Word Search 2, Lead Code Problem 212. So for the input, you're given a 2D array, which is a board of characters, and then you're also given an array of words. And so you're supposed to search through this board character by character, and if you can find the words that are connected up, down, left, or right, then you are to return that in your output. You can reuse a letter only in a separate word. You can't reuse a letter within the same word, and you can't go diagonal. So for instance, in this case, eat is returned because A is to the left of E and T is to the left of A. In this board, the output is nothing because the word you're looking for is A, B, C, B. And so for two reasons. One is that C and B are connected diagonally, and also B is used 2 times. So for that reason, it can't be found. To solve this, there's 2 big steps. The first one is to create a trie class and then add the words to that trie. And the second thing is to go through the board. If you find a character that one of the words starts with, search up, down, left, right, and if you continue to find a letter, recurse on that. So let's take a look first at what that looks like visually to create that trie and add words to it. Visually, what it looks like to construct a trie. So for the first thing that we do is we create a trie class. So a trie contains 2 elements in its class. The first thing that it contains is a hash map. In that hash map, the key is going to be the type of a character, and that character is going to point to a value, which is going to be another trie. So the character points to another trie. So you see whether or not that character is connected to the next letter. And the other type that a trie contains is a Boolean. And this means that does this character reach the end of the word, and that is going to be true or false. When it's initialized, it is set to false unless you have reached the end of the word. So that's the characters to tries in the hash map, and then the Boolean is the other type. So in our example here, these are the words that we want to add into this trie so that they can easily be searchable. The first word is oath. The second word is eat, then pee, then rain, and then let's also add oat to this trie so we could see how that works. So there's a couple of steps that we do for every new word that we're adding. So we are going to do a couple of loops. We'll do word by word, and then character by character. So for every new word, we're going to make a new trie. First step is we are going to make a root. And For every new word, we are going to have our new trie set back to the root so that those are all connected. So we have a new word, we are going to set it to the root. So let's start with our first word, which is oath. So here's oath, and we'll say, does O exist in this trie? No, it doesn't. So we are going to make an O key. Then we are going to make its value be another trie here. And then that trie will be our current trie. So then we're going on to the A letter, and we'll say, does A exist as a key in this trie? No, it doesn't. So we'll make A as a key, and then its value will be a new blank trie. And then this will be our current trie. Then we're on T. We'll say, does T exist in this trie? No, it doesn't. So we will make T as a key, and what will the value be? A new trie. Then this will be our current trie. We'll say here, does H exist as a key here? No, it doesn't. So we are going to add that to our trie, make a new trie, and then that will be our current trie. We are at the end of our letters. We have no more letters left. So what we are going to do here is just write true in this trie. And there's no keys or values, or it doesn't point to anything else. So that is how we are mapping oath. So now we're on a new word, so we're going to make a new trie, and we are going to point it to the root. So we are going to be right back here. The root has O as a key, but it doesn't have E as a key. So we'll make E to be a key. We will make a new trie, and then we will point to that trie, and then that will be our current trie. So in our current trie, is A a key? No, A isn't a key, so we are going to make that a key, and we are going to create a new trie then, and then that is going to be our current trie. In our current trie, is T a key here? No, it's not, so we're going to make T to be our current trie, then we are going to point to a new trie. We have no characters left, so what we are going to do is just write true for the Boolean in here. I'm going to just fast forward and do these all for the next letters. So we are creating a new trie pointing to our root, and I shouldn't have that trie yet. Pointing to our root, and we're saying, does P exist here yet? No, it doesn't. So P is going to be a new key, and it's going to point to a new trie that I create. And then this trie is going to be my current trie. Then we're going to say, does E exist here? No, it doesn't. So we're going to create a new trie and point to that trie. Then we will say, does A exist here in our current trie? No, it doesn't exist, so we are going to create that key, and that value is going to be a new trie. Then does T exist here? No, it doesn't, so then we are going to create a new trie, and then that is going to be our current trie. but we are out of characters, so we are just going to write true here. So I'm going to skip over P and rain, but let's go back to oat here. So say I need to add oat into this trie. I'm going to create a new trie, point to the root, and so I have this root here has keys O, E, and P. So again, I asked myself, does O exist here? Yes, it does. So then I'm going to get the trie that it in its value, which is here, and then that's going to be my current trie. Then I'm at A. Does A exist as a key in here? Yes, it does. So then I'm going to get the trie that it's pointing to. Does T exist here? Yes, it does. So I'm going to get the trie that it is pointing to. And now I am at the end. I have no more characters. So in this node, I am going to change the Boolean value to true here. And that is how I construct the trie for, we added oaf, eat, P, and oat over here. You could see with rain, it would just be R pointing to a new trie, etc., until it got to N and it would have a trie that points true to. Okay. Okay, so let's create the trie. Very easy. Having a new object called trie, and again, it has two elements to it. It has a hash map with a character key, and that character points to a value that is also a trie. It also contains a Boolean, which is whether or not that is a word, and it's initialized to false. I'm going to include the constructor here, which is just an empty constructor, and that's just going to say if you want to make a new trie, you don't have to put anything in it. It can just be blank, but you will have a hash map and you will have a Boolean in it. Okay, so let's add all of the words to that trie. So we have our root. And then we are going to go word by word, which is going to be for every word in the words array. And then for every character in the words, that each word. So we'll have our trie current, which is going to be set to the root. And then we have our logic here with every character that we go through. So we'll say if the current hash map has this key, we're going to get it, and we'll say the current is equal to current hash map get C. So then we will be on that trie that the character is pointing to. Else, we are going to make a new trie node. And we are going to take our current hash map, and we are going to put that character and then the new trie node. And then our current is going to be that new node that we just created. And then after we get through all of the characters, we are going to say that current trie, the word is going to be equal to true. So that is creating the trie class. Now we're going to have to search. So looking at our method signature here, we are going to have to return a list. So I'm just going to initialize that right now. And once we go through our search, we are going to be returning that same answer. So we have to do a nested loop to search through this 2D array, because we're going to be looking at all of these characters and see if we can construct a word from it. I is less than board length, I plus plus, and then within that I, we're going to say for int j equals 0, j less than board of I, length, j plus plus. So if the root has the letter that we're looking at, the root hash map, we are going to search from there. And then let's take a look at what that method signature will look like. I'll make a new method. I'll call it search. It's not going to return anything, it's just going to search. So for that, we're going to have to pass the index I, the index j. We're going to also have to pass the trie, starting with the root. We're going to have to also pass the board, because I don't want to make the board a global variable. I'm just going to keep passing it through. We're going to pass the answers list so that we can keep appending that. And then we're also going to pass a string. And what that string is going to be is the current state of our search. So for instance, when we search, we're going to send I, j, we're going to send the root, we're going to send the board, we're going to send the answers, and then we're going to send the character that we're at right now, because we know that it at least begins a word that we're searching for. And to convert it to a string, I'm just going to append this blank string right here, and that will automatically convert that type to a string. So after we search, when we find the beginning of a word, we can return the answer. So let's see what our search is going to look like. So there's a couple things that we have to do. So first of all, we don't want to keep on searching over a letter that we already counted in our string. So we're going to cache that letter that we're currently on. So that's going to be board IJ. Then we are going to get the trie this character points to. See if the word is equal to true. If yes, add it to the answers. After that, if it doesn't get added to the answer, we are going to update the board to have that character equal to a tilde so that we don't keep counting it again in our string. And then we are going to search right, I'm going to just comment this out, search right, left, up, down. And then restore letter to board. Okay, so I'm going to say character letter is going to be this character that we have here. The trie is going to be this letter, and now we're going to say check to see if this word is true, are we at the end of do we have a complete word here? We're going to say answer add s. Before we do that, we're just going to make sure that it's already not added, because you can find the word in more than one ways. So if the answer doesn't have s, we are just going to say add s there. I'm going to put that in brackets just for readability. That is this over here is what we're doing. Okay, we'll update the board here. So board I, j is going to be equal to this tilde. And I just made it to a character that is not going to be part of a word. So that's why I chose the tilde. We're going to search up, down, left, right. But after we do that, we're just going to restore it. So let me just write this here first. It's going to be equal to letter. All right, so searching up, down, left, or right. Right would be I plus 1. And we want to make sure that we are not going to go outside of the board. So if I plus 1 is less than the board length, and this character that we're at, this I plus 1, if the current trie has this key, that is the next character to the right, we're going to keep searching for it. So we'll say here, if I plus 1 is within this board, and then this trie points to, or has this, if this trie has this key of the character that's to the right, we're going to continue searching through there with I plus 1, j, the current trie, board, answer, and s plus board I plus 1 and j. So let's do that now to the left, which would just be if I minus 1 is greater than or equal to 0, and the current trie has the key of this character that's to the left, we're going to search to the left. And let's do that going up or down. So we could say if j plus 1 is less than the board of I length, and the current hash map has the key that is up, which would be board I, j plus 1, we are going to search that way. We're going to search I, j plus 1, the current trie node, the board, the answer, and s plus board of I and j plus 1. And if I copy this without making an error and updating it, let's go j minus 1 is greater than or equal to 0. And the current hash map contains the key that's at j minus 1. We are going to search j minus 1 and append our string with this character also. Okay, let me see if I have any errors that I can see right off the bat. If I run this, I might have some syntactical errors. Let's see. Line 27. There's a space here. And package root does not exist, so try cur. This is going to be T right here. It's not the root. Okay, so some syntactical errors, but generally okay. And if I submit that, it's not super fast, but I can make the code a little bit more succinct, for instance, in this part here. I feel like the way that code is written is more intuitive, so you can, but it is a little bit long. You can create some arrays here and check immediately if it's out of bounds. But I feel like this is sort of the most succinct way of writing it. And I'm going to move this over here. You can see all the code. So it's a little bit long, but I feel like if you get all the steps right, I think it should be pretty intuitive so that you don't have to have all of this memorized. Okay, thank you.